Good morning or good afternoon or good evening, wherever you're calling in from. This is Panama Bartholomew with the Building Decarbonization Coalition, and welcome to a very special edition of Building Decarbonization Presents with special guest presenter, New Buildings Institute today on our topic for today, the retrofit ready heat pump water heater, 120 volts to the future, where we talk about 120 volt heat pump water heaters that are coming to the market. We're really excited about today's session. We're really excited you joined us. We had over nearly 450 different people register for this webinar, and so we know there is excitement in the field for this product offering coming. So we're going to get right into it. I'm just going to give a little bit of a background on the coalition, and then I'll introduce our speakers and we'll get right into it. Next slide, please. So the Building Decarbonization Coalition, it's a collection of energy providers such as utilities and CCAs, manufacturers of heating equipment, the design and construction community, local governments and NGOs, all working together to eliminate emissions from the built environment. We work on both policy and market solutions, historically focused in California, but we are going to be expanding this year into New York and other states as well to be helping coalitions in other states work on building decarbonization. Next slide, please. We developed and adopted a roadmap back in 2019 to lay out a vision for California's decarbonization of the built environment. Next slide, please. And in that, we had a series of goals that we laid out that were going to be necessary for California to eliminate pollution from its buildings. We agreed as a coalition that the state should be adopting zero emission building codes for residential buildings by 2025 and non-residential by 2028, and that the state should implement a whole series of programs in order to address existing buildings and reducing pollution from existing buildings. Inherent in that was a recognition that if the state is going to meet its climate goals of carbon neutrality by 2045, we can't be installing fossil fuel appliances much after 2030 here in the state. And so the roadmap also called for a shift in the market so that by 2030, water heating and space heating equipment would all be zero emission. All units would be zero emission sold from that date forward. Next slide, please. Behind those numerical goals, though, is a recognition that a series of market and policy goals were going to have to be met for those numerical goals to be possible. And so after about 5 months of discussion and looking at every market barrier that exists for building electrification, the coalition agreed to these 5 major goals that guide our effort. Number 1 is significantly raising awareness of the benefits of building electrification. Really across consumers, supply chain, policymakers. Goal number 2, making sure that customers get a good value proposition from building electrification. And this means that we have the upfront costs provide a good value, as well as the operating costs are a good value compared to fossil fuel appliances. Goal number 3 was a recognition that people actually need to be able to build sustainable businesses around building electrification. And we need to make sure that building decarbonization provides a better value to builders and contractors than installing the fossil fuel appliances. Number 4, that we are supporting the supply chain with transparency and consistency of policy, so the supply chain is able to adapt to where the state is going on climate and clean air policy. And also we're getting barriers to the supply chain out of the way, such as a lack of adequate infrastructure in buildings or a workforce that needs training. And then number 5, really aligning policy so that all of our policies, our energy efficiency policies, our construction policies, our climate policies, our refrigerant policies, et cetera, are all in alignment and moving in the same direction and sending a very clear message to the market around where the state is going. Next slide, please. This webinar series, back one more, please. This webinar series is part of the way that we carry out goal 1, raising awareness. This webinar series, we bring together some of the top thinkers and doers within the building decarbonization space on a monthly basis to allow them a chance to talk about what they're building, what they're deploying, what they're thinking, what they're excited about, and we're very excited that you joined us today for this. Next month, next slide, please. Next month, we have a very exciting webinar about carbon neutral coffee. Quick raise of hands, who likes coffee? All right, I see that most of you, fantastic. Well, Bellwether Coffee produces all electric coffee roasting equipment. You get the question a bunch when you see REACH codes being adopted, and how are we going to deal with food service, and in particular, how are we going to deal with coffee, with the coffee roasting surge and the coffee revolution that's happened over the last decade as well. Well, Bellwether Coffee is really leading that revolution, and I hope you tune in next month, June 10th, 10 a.m. Pacific time, to hear from Bellwether Coffee and the journey they're on and what they're providing as far as all electric coffee roasting equipment. You can go to our upcoming events website to register for this webinar and other webinars that we offer. Next slide, please. So just some logistics before I introduce the speakers. Everyone is muted. We have about 234, 235 participants, so we couldn't have you all unmuted. So please ask your questions via chat, and we'll ask them of the speakers. We may unmute you if it's a particularly good question and let you ask it. This webinar is being recorded, and members of the coalition can access the recording on our website after this webinar is over. Move forward a little bit, Lawrence, please. But there's also many other great benefits about joining the coalition. Take part in working groups with other leaders within the space, be kept up to date on everything that's happening on the policy front at the national, the federal, state, and local level for building decarbonization, and just be part of a really fun crowd with great happy hours and community building events as well. So please feel free to join into the coalition. Next slide, please. So I'm going to start to hand it over to the first speakers. Here's what we're doing today. In 2018, 120 people got together in San Francisco and met for 2 days around issues of heat pump water heaters, and in particular, California's problem with undersized electrical panels and a lack of a whole bunch of 220 volt wire running through their residential buildings. Out of that 2 days of communications between utilities, policymakers, installers, and OEMs, there came working groups that worked on a specification for 120 volt heat pump water heater, as well as a policy framework about what California has to do to really ramp up the demand for heat pump water heaters. So fast forward 2 years now, and what we're going to do is we're going to hear from the Advanced Water Heating Initiative, really the initiative leading the conversation nationally about advancing heat pump water heaters. And they're going to give you an overview of the initiative and how 120 volts water heater fits into that, heat pump water heater fits into that. And then we're going to hear about the 3 manufacturers that are currently bringing these products to market. And so it's Amruta is going to talk for about 7 minutes on Advanced Water Heating Initiative. Each of the manufacturers are going to talk for about 15 minutes. And then we're going to have a lot of time for questions and answers afterwards. Each of them are going to talk about estimated product availability and what they're thinking and where it's at. And so then we'll also have contact information for each of them afterwards as well, so you can reach out to them if you want to learn more about their products. So at this point, I'm going to hand it over to Amruta Kanolkar. She leads the Advanced Water Heating Initiative, which, as I said, is where the national conversation is going on advancing heat pump water heaters. And we're really excited to have NBI partner on this and for their leadership in this space. So with that, I'm going to hand it over to Amruta, and everybody please enjoy the webinar.
Thank you, Panama. Thank you for the warm welcome and introduction. Hello all, I'm Amruta Kanolkar, project manager at New Buildings Institute. And today I will be giving you an overview of the retrofit ready heat pump water heater field study and commercialization effort that is happening as part of the Advanced Water Heating Initiative. Next slide, please. So what is Advanced Water Heating Initiative? A quick intro. It's a collaborative effort of over 50 plus organizations, market transformation initiative to help accelerate the production and adoption of heat pump water heaters. And the initiative is led by New Buildings Institute in partnership with SMUD, Southern California Edison, BPA, and NEA on the West Coast. And what you see on the right is the organization types. Like, there are like very different types, from manufacturers to utilities to program administrators. A lot of like different organizations and inputs from different perspectives. As part of the initiative, we have 4 working groups, and one of the working group is focusing its efforts on 120 volt, the retrofit ready technology advancement and commercialization efforts, led by Jim Lutz from Hot Water Research. Next slide, please. So I wanted to give you some idea into the opportunity this technology, if validated, has. Like, for example, there are about 118 million retrofit like existing water heaters in the residential sector and about 4.6 million in the commercial sector. And just to give you some context, there are about 14 million water heaters just in California. So that's about 12% of the national water heating stock. And overall, like, there are 40 million water heaters that are 10 years and older. Typically, water heaters lifespan is about 12 to 14 years. So you see that about 40 million water heaters are about to like close to the end of their life. 7 million water heaters get replaced every year. So this technology, again, as I said, if validated, has tremendous potential to decarbonize the water heating sector. Next slide, please. So this slide gives an overview of the fuel mix, the water heating fuel mix nationally and also in different regions. So nationally, which is the last row, the electric to gas water heating like fuel mix is about 50%. But if click next slide, please. But if you look at California, about 90% of the California's water heating stock is directly pumping fossil fuel for heating their water. And water heating with natural gas represents one of the largest greenhouse gas emission end use in typical residents in California, including multifamily. It's the largest energy consuming end use as well as greenhouse gas emission end use, specifically in California. So if you go to next slide. So why is this technology needed? So for that 90% of the those 90% of the consumers, if they want to decarbonize and switch to an electric water heater, the only option they have currently is going for expensive and extensive panel upgrades. Next slide. So only going for extensive and expensive panel upgrades. So this technology, if validated, will no longer require that. So the plug-in heat pump water heaters will be able to just plug into an existing electrical outlet. Next slide, please. So that's a little bit about. I wanted to also give you an background on about the technical specification. So as Panama mentioned, as part of the Retrofit Ready Summit, the technical specification and the program framework stemmed as part of the summit, and now in 2019 they were written, and now they are part of the advanced water heating specification. About 5 to 6 products are expected between this in this year to be like market ready, production ready, which are like following the specification that were developed. So we believe that if we use the consistent field test methodology and data collection methodology, this technology can this whole effort can really help with quicker and more accelerated market adoption. Next slide, please. So wanted to give a quick overview of the field study. So the objective of the field study is to independently field verify this emerging technology and also help with quicker market adoption and commercialization efforts. The research is based on, like, the focus areas of the research is to study the user satisfaction, making sure that the technology is delivering enough hot water, also understanding the operating cost, the energy and load performance, and the installer and consumer experience. We are trying to capture diversity when it comes to site selection. So in the site parameters, we are focusing on 4 different, like, critical parameters. One is the building type, which is single family, multifamily, manufactured homes. Also installation location, whether it is installed in garages, in internal closet, external closets, the different climate zones. I do want to mention that we are looking at about 36 sites in California and about 10 sites on the Northwest to give us the climate variations. Even in the California, we're looking at different climate zones. And then finally, the demand and tank sizes. So, whether it is low demand application or high demand application. Next slide, please. So we are doing that, like, to gather both quantitative and qualitative, like, feedback we receive for the technology. We are basing it off of, like, metering, energy and cost analysis, and, like, also we will be also surveying the consumers, installers and manufacturers. So those are the critical methods that we plan to use. Next slide, please. And as I mentioned, again, the main goal of the field study is to help expedite the commercialization and market readiness of this emerging technology. So the plan is to, once the field study findings should help with the work paper process, like work paper writing, and also adoption of this technology into the existing heat pump water heater programs, and raising awareness and build and building trainings to train the workforce and consumers, and finally work purchase orders. So with that, I wanted to mention that currently NBI is working very closely with the manufacturers and the utility providers, and we are looking for more participation from electricity providers. So if you are interested, next slide, please. Please get in touch with me at amruta@newbuildings.org and join the effort. With that, I will thank you all, and I will hand it over to Tom, the next presenter. Here you go, Tom.
Thank you, Amruta. I really appreciate that, and I appreciate everyone's time today. So I'm Tom Zimmer. I am the leader of our water heating business for GE Appliances. And as we had the opportunity to bring our thoughts into the discussion today, one of the things I wanted to do was to make sure that we touched on something Amruta just mentioned, and that is the importance of the owner experience. Next slide, please. So I'm going to cover a number of topics today. You can see them listed. I'm going to go ahead and move forward, and we'll jump right in. So when you think about what will be a key to make the conversion feel like a natural option for consumers, obviously it's going to be, the performance that they experience with the products we bring. It'll be the cost of installation or readiness of their home. It'll be what are the trade-offs that they're experiencing relative to energy cost, the efficiency of the product that they bring, and ultimately the cost to get the product into the home and have it installed. Next slide. So when we think about the owner experience from a performance standpoint, the kind of things you can expect to hear from these owners is that, they're always happy to bring in new technology as long as it isn't causing them to give anything up or to inconvenience them. So we've identified a few things that are key from a user perspective that we think will be things that we have to monitor through the field test to understand, are they experiencing inconvenience? Are they dissatisfied in any way? And then ultimately, accomplishing goals for other purposes is always something people accept as long as they don't have to change their lifestyle. And finally, you know, the questions in general around, do heat pump water heaters work as well as the old gas water heater did? And this is something that, you know, even as we've gone after the 240 volt heat pump water heater conversion and adoption, continues to be a bit of a challenge. Next slide. Obviously, the cost of preparing for the installation and readying the home, you know, this is, Amruta touched on this, there are situations in many of the homes, particularly in California, where the panel doesn't have adequate ampacity available for a 240 volt. And as a result, the desire is to use a 120. And strong desire would be to use an existing 120 circuit. Next slide, please. And when you think about the energy cost trade-off between a heat pump and a gas water heater, this can vary depending on the region that they're in and whether they're on time of use rates. So the things that you can expect are noted below. Some of the things that consumers will be challenging around, why would I want to make this switch? And does it really offer a payback story for me or a benefit to my total energy cost for my home? Next slide, please. This is just an example supporting that. Again, you know, these are just typical examples of cost of operating a 40-gallon gas product in the $200 range for annual operating costs versus a heat pump that would meet their requirements in a 240 volt configuration at about $160 to $170 a year. So again, there is some savings, but it's marginally not massive. Next slide, please. And of course, there's always consumer skepticism. You know, is the efficiency claim I'm hearing about real? Is it really going to save money? How much will it save me? And in some cases, questions around, does efficiency mean I'm going to be inconvenienced or that I risk running out of hot water? Next slide. And finally, the acquisition cost of the product itself. Heat pump water heaters typically will be more expensive than the gas water heaters would be if you were replacing with a like product. So the challenges that come with having ready cash, ready to pay the difference, and an expectation that that there's going to be a higher installation cost as well, all create barriers that we have to be aware of as we think about some of the reluctance that you can expect as we try and make this change and we go after decarbonization. Next slide. So again, when you think about installation characteristics, the bulk of the products that are out there in the gas market today are natural draft or atmospheric type models, as shown on the left. Those that are out there that are installed with power vent or power damper features do have an available 120 volt 15 amp circuit already there. Things that you've got to look at as you try and convert, you want that installation to be as standard or common as possible between these installations and what we require for the heat pumps. Next slide. So again, when you look at that, you want to maintain the top port water connections to the degree possible. You want to be able to operate off of 120 volts so that it's an easier circuit or an easily expanded circuit to create in the home, or it's a condition that you can take advantage of that existing circuit. You need to be aware of the installation space consideration and any changes that a heat pump may bring to that. Very few are expected, but one of the characteristics of heat pump that you do need to manage is the condensate that's associated with the system. And then clearly the proper sizing and capacity and consideration around first hour rating and recovery becomes crucial to create that owner experience that's going to be acceptable to the owner. Next slide. So this is just a quick table to try and give a typical comparison. So if you looked at heating capacity across the technologies available to consumers in the home, from their perspective, they could choose to operate on natural gas or electricity. with electricity. They could use a standard electric tank or a heat pump water heater. And as you step across the characteristics that they will feel as differences in their use, it will be revolving around how long it takes to heat the water or reheat the water, and how much water do they feel as being available during typical use. The standardized test that manufacturers use to characterize this is the first hour rating, which is reported on the energy guides. And these are just examples to give you a sense of what are the trade-offs that exist between first hour rating, recovery time, and available water for that user in the home across these technologies. Next slide. What you'll notice is that when you move from the 240 volt to the 120 volt configuration, you are giving up energy use on the input side. So it takes longer for tanks to recover, especially those that are operating on pure heat pump operation. And there is a tendency to get lower first hour rating as a result of that difference. Next slide. So the ways you would typically overcome that, even if you were switching to a 240 volt heat pump, is there is typically a recommendation that if you're operating on a given size tank for your gas heater, if you're going to install a heat pump behind that, you will want to step up the capacity to be able to get to that first hour delivery that you've grown accustomed to in your use pattern in the home. Next slide. When you move from 240 to 120, that first hour delivery is impacted in the rate of recovery, and it reduces the amount of first hour water that you're able to get net from the product during that standardized test. So, you know, in round numbers, you'd nearly have to double the tank capacity to get comparable first hour delivery. You know, something we've got to factor in as we think about these conversions. Next slide. So one of the ways that GE is approaching this problem or this challenge, we have developed an innovation that we're applying to standard electric heaters today for flexible capacity and to create the opportunity to boost the performance of a unit for first hour rating on an as needed basis. With an integrated electronically controlled mixing valve, we're able to elevate the temperature of the tank as needed and allow that unit to perform as a larger tank. So first hour rating behaves as a larger tank. And you can see that this gives us a lot of flexibility in how we serve customer needs and varying customer needs in the home. Next slide, please. So when you think about what that can do as you consider this 120 volt heat pump challenge, it gives us that opportunity to maintain the first hour rating in a way that gives us equivalent first hour delivery from a tank size that doesn't become so large that it doesn't fit in the application in the home. And this is one of the differentiating things that as we are tackling this problem, you will see coming in with that product development. Next slide. Of course, as you drive the energy, the temperatures in the tank to a higher level, you do have an associated energy penalty that comes with that. Still a very efficient product, but it does in fact have an effect by driving the tank temperature higher. Next slide. And when you look at what that capability enables, when you do comparisons across, in this example, 50-gallon heat pump tanks with and without the use of the mixing valve, or typical 40-gallon gas heaters, what you'll find is that you can not only meet, but you can exceed that first draw capability of a similar tank, with the intent being that this gives you the capability to not have a consumer or a homeowner that feels challenged in the available hot water in their normal behavior. Next slide. So this is my my advertising page. So the product that we're in development on right now is going to be our GeoSpring heat pump. Again, with the capability to operate on either 240 or 120 volt circuits. We will be bringing in the feature that I had just described relative to an integrated mixing valve on a variety of tank sizes. communicating capable through a CTA 2045 compatible module, and also inclusive of an onboard Wi-Fi module so that we have direct capability to connect. And it does maintain those common top port connections. And with that, I will thank you for your time, and we can move to the next slide. I'll be happy to pass this presentation to Arthur Smith with A.O. Smith.
Hello. So my name is Arthur Smith. I'm a product manager at A.O. Smith Water Heaters, and I'm responsible for many of our high efficiency residential water heaters, including our hybrid electric heat pumps. So I'm excited to be a part of today's conversation and share some of the things A.O. Smith is working on. Next slide. So the concept of heat pumps is pretty simple. We're talking about that it's much more efficient to move heat from one place to another, or to move heat from one place to another rather than generating heat directly from an energy source. So for heat pump water heaters, you're generally talking about transferring heat from the ambient air into water, and that's most of the time more than 3 times as efficient as a standard water heater. So A.O. Smith is proud to have a full portfolio of heat pump water heaters, and the intent is to cover a whole range of applications. So if you could click once. So we use hot water in all aspects of our life, at our home, at work, in travel, hotels. But each of these applications has slightly different needs. So we've manufactured a bunch of different products to meet these needs. If you could click once. So we have our standard 240 volt heat pump, really designed for the residential applications, or in multifamily, or you have one water heater per unit. Please click. We have commercial split systems that could be used in multifamily that uses a central water heating system, as well as in commercial properties. You could click again. We've got a unitary commercial heat pump for smaller commercial jobs. Click one more time. And then obviously the topic of today's meeting, but we're in development of a plug-in 120 volt heat pump, really targeted specifically at the existing home stock and converting them from gas water heaters to electric heat pumps. Next slide. So just to kind of quickly running through our product offering, we've got our standard 240 volt residential heat pumps. These are really well suited for new construction or replacing a standard electric water heater. They're highly efficient, up to 3.45 UEF, and over almost a decade of use, they've proven themselves to be quiet and dependable water heaters, which are really what people are looking for at the end of the day. If you go to the next slide. Last year, we expanded our standard residential heat pumps with some new JA13 certified models to meet the new incentive or voluntary standard for heat pumps in new construction in California. So these incorporate some new functions for us, such as Wi-Fi and Bluetooth connectivity, and connect through the A.O. Smith app. They also have some additional opportunity to save a homeowner even more on their utility bills by taking advantage of utility time of use rate schedules, so that the water heater will operate when electricity is least expensive. And finally, these are also capable of demand response via OpenADR. Next slide. So the residential models are generally undersized for commercial water heating requirements, where they use more hot water a day than the residential ones residential heaters can deliver. So we've also developed a portfolio of commercial products. We have this unitary commercial heat pump that combines a heat pump and 119 gallons of storage in a single package to make it easier to install, basically as a direct replacement for a commercial electric water heater. These are highly efficient with over a 4 COP, so there's huge savings potential in operating cost when you're talking about replacing a commercial electric water heater. Next slide. We also have a full range of commercial heat pumps, and we can work with you designing a package system, combination of heat pumps and storage to meet really any application. So we've got a whole variety of heat pumps, air and water source for indoor or outdoor applications in single pass or multi-pass systems. And that's a lot of descriptors right there. But the idea is this gives a huge amount of flexibility in how we put together a system to meet the needs of any specific project. Next slide, please. So finally, we recognize the need to make it even easier to replace a gas water heater with a heat pump. There's some constraints when you look at trying to use the 240 volt heat pumps, when you put them, using those to replace a gas water heater. So a couple of the key ones, fitting back into the tight installation spaces that gas water heaters can fit into, whereas heat pumps generally need access to more air to operate. And then homes designed with a gas water heater probably don't have, or they may not have 30 amps available in their electric panel for a water heater, and they certainly do not have a dedicated 240 volt circuit for a water heater. So our goal here was to make it very simple to replace that gas water heater. If you could click once. So just as a visual, here's a pretty typical water heater closet next to a furnace. In this case, it's a power vent. But the intent here is, if you could click once, be able to design and fit a heat pump back into that same space. If you click once more, they can plug right into that outlet that's already available. Click one more time. So I did want to highlight that, homes that already have a standard electric water heater, they can go ahead and convert to a heat pump using the existing 240 volt products that are already on the market. So the 120 volt is really your replacement for a gas water heater. Next slide. So we're excited to announce that A.O. Smith is developing a 120 volt plug-in family of heat pumps that'll be coming soon. These are designed to plug into a standard residential outlet, specifically a 120 volt outlet on a 15 amp shared circuit. So being able to plug into a shared circuit should make it easier to install, because you're basically leveraging the home's existing electrical system and able to install with minimal or ideally no electrical work, because you're using an outlet that's already in proximity to where the water heater is located. We'll have 120 volt plug-in models in a variety of capacities. This was important to us to make sure that we had different footprints that could replace gas water heaters, because it's very difficult to open up additional space in an existing home. Since our customers buy water heaters first and foremost to have hot water, we've gone to great lengths to make sure that our 120 volt models will meet Uniform Plumbing Code sizing requirements, using that first hour rating that every water heater gets. So that was critical to us, because the 120 volt particularly when you put it on a shared circuit, it will have less heating capacity or less power available to it. So we had to get creative in terms of how we would design our products and still meet the sizing requirements. And finally, our 120 volt models will include some of the same advanced functions that we added to our standard heat pumps. They'll meet the California JA 13 requirements, including supporting time of use rate scheduling. And they'll also support demand response via CTA 2045. Next slide. So just as a parting note, I did want to share some of the takeaways that A.O. Smith has found over many, many years of selling heat pumps across the US. And we think these are the keys to driving heat pump adoption in California, but across the country. So first, it's important to have programs specific to new construction. This is by far the easiest time to install a heat pump water heater. And they can be using products that are already commercially available today. Second, there are a whole bunch of different rebate program styles, but instant rebate programs are the way to go. A water heater replacement is generally, an unplanned and an emergency expense for a homeowner. And so the upfront cost is the biggest barrier to selecting a heat pump. Mail-in rebates have been widely used, but generally speaking, they don't influence the purchase decision because the customer still has to pay that full cost up front. So mail-in rebates implemented either upstream or midstream have been very successful at driving heat pump adoption. And I've listed several case studies or several implementers below that would be good case studies for how to successfully implement an instant rebate. Next, water heater sales are pretty well split between the wholesale and retail channels. So it's essential that you design programs that support both of these channels. Otherwise, you're effectively ignoring half of the potential heat pump conversions. We've seen advertising campaigns be very effective at driving proactive replacements. And when you shift from emergency to proactive, it gives the customer a lot more time to research their options, learn about incentives, really understand the value prop, and they're much more likely to choose a heat pump. Finally, it's essential that we have plumbers and installing contractors be a partner because they are a trusted source of information and their product recommendations carry a lot of weight with homeowners. They've got a lot of influence. It's essential that they see the value of heat pumps and that they're an advocate for the technology. So at A.O. Smith, we're always happy to partner with others to provide training on heat pumps and programs. I think the one key for California will be demonstrating heat pump operating costs that are lower than natural gas. So I think time of use pricing will be a key there. So these are some of the lessons we've learned over almost a decade of heat pump sales, and excited to see where this industry goes next. At this point, I'll turn it over to Kevin from Rheem.
Kevin, we don't hear you again, unfortunately. Yeah. So it does look like you're unmuted, but still no sound. So why don't you keep talking and we'll try to figure that out. And in the meantime, I'll ask some questions from folks that have been coming in. We have a very active chat coming in right now. Arthur, you were necessarily coy about timing, coming soon. we don't want to hold you to anything here, and this is being recorded, so just if you're warned. But do you have an idea, you know, Q3, Q4, when you think the 120 volt A.O. Smith models will start coming out?
I would say this year, but that's about as specific as I'll get.
Yep. Great, thank you. And for both Tom and Arthur, there's quite a bit of questions about both noise and refrigerants. Kevin, you back in?
I am. Can you hear me?
We can. I'm going to hold off those questions, but everybody get ready for lots of questions about noise and refrigerants. And with that, we'll hand it over to Kevin Clark with Rheem. Take it away, Kevin.
Thanks, Panama. Sorry for the technical glitch. You know, of course, that's the world we live in right now in COVID land. So I wanted to thank the BDC for allowing us the uncomfortable opportunity to present products that are not in the marketplace as of yet, especially in front of our competitors. So, you know, again, we're super excited about this product. We think it's going to take an important role in the decarbonization efforts of not only California, but a lot of the states that choose a decarbonization pathway going from gas to electric. So as many of you know, we have 20 unique SKUs in each of our brands for current 240 volt heat pump water heaters or hybrid electric water heaters. So we are very excited to announce launching this summer 6 new SKUs for 120 volt products. So again, these will be in you know, local distribution in California, as well as hopefully some retail spots for these 120 volt heat pump water heaters. So why don't we go ahead and go to the next slide. So we're coming with a couple of different options. You know, again, we want to make sure that we have a product that's going to suit the needs for the consumer. As you've probably already gathered from the other manufacturers, hot water to the consumer, you know, we want to make sure they're having a good experience with that heater, because typically either ourselves or our plumbers out in the field are going to get that complaint if they actually do run out of hot water. So we did develop a dedicated circuit model, which will have higher recovery, very similar to the predominant 38,000 BTU 40 and 50 gallon options out in the market today. So it's kind of a good direct replacement. It will require a dedicated 120 volt plug-in circuit. Many of the homes for the past 15 years have that dedicated circuit already installed, as builders were putting that option in for future, you know, high efficiency gas products. Now we're going to be utilizing that built-in circuit for heat pump water heaters. But for other applications, we are coming out with a shared circuit heat pump water heater. It will have a integrated mixing valve, which we are calling our Hydro Boost. So it will be able to provide very similar hot water delivery, and it'll have you know, more size variance in order to meet the needs of the consumer. Go ahead and go to the next slide. Again, you know, the intent of these 120 volt products is to, you know, have a direct replacement without any penalty in hot water delivery for the consumer. So we wanted to stress the fact that this is a quick and easy replacement for the gas water heater. As you all know, today, if a person chooses a 240 volt heat pump water heater, it kind of eliminates that DIY process of going to your local retail store, picking up a water heater, and being able to install it in that same day. You know, typically there's an electrician involved, as well as a plumber, which increases obviously the installation cost, making it a huge barrier. So that's why the market really asked for these 120 volt models just to get out into the marketplace. Go ahead and go next slide. So again, this is this is a very easy installation. It makes it very simple. You just plumb it in and plug it in, and the homeowner will have a good delivery of hot water. You know, of course, we're going to have a lot of tools for consumers and for contractors to make sure they are placing these in the right applications. So we again want to make sure that you know, you're not putting a 40-gallon heat pump water heater in a 4-bedroom, 4-bath house with 8 people in it. So we know nobody's going to be happy with that situation. So we make sure that whether it's going to be a 240-volt or 120-volt product, that the right water heater will be selected for that application. So we go to market with training in a lot of different ways. We have an innovative learning center in Oxnard, California, that we're really excited to open back up again here in the fall, to bring plumbers in to train them on efficient products like these heat pump water heaters, and really, you know, get them tuned up on how to sell, service, and install, you know, high efficiency options. We also go to market with our sales agency, Mega Western in California. So they are our boots on the ground. They own a lot of relationships with plumbers and distribution, and talk to them on a daily basis to train on plug-in heat pump water heaters, as well as, you know, resources like myself. We have a builder group, as well as a distributor group of Rheem employees that go out, and again, they help train the marketplace on heat pump water heaters. So go ahead and go next slide. We all know the real reasoning to switch to, you know, these all electric products. You know, again, we kind of took a stab at the carbon reduction, going from a atmospheric gas type product to this plug-in model. And you know, again, this is national average. You're going to get a 79% reduction in carbon. That, of course, is national average. California is way ahead of the curve as far as how many renewables and clean sources of power generation are on the grid. So that is actually looking even better than in California than it is in other parts of the country. We, you know, of course, really wanted to make sure that the hot water availability is going to be there for the consumer. That's why we have a couple of different models, and the reason why we've included a mixing valve to be able to ramp up that internal temperature of the water heater in order to deliver enough hot water for the family every single day. And of course, energy efficiency, it's a slam dunk. You know, you're going from a 60% gas product to a heat pump water heater, so you're going to get 5 times the efficiency just switching those water heaters out. Go ahead and go to the next slide. And really, you know, at the start of this is going to be a pretty California specific product, as you know, we see incentives go or incentivize from gas to electric. Other areas still have to get that completed. You know, if they're only incentivizing electric to heat pump products, obviously the 240 volt is a natural selection for those areas. But again, as you know, other parts of the country start to look at fuel switching options, or say if you know, homeowner puts solar on the roof and they want to ditch the gas bill on top of the electric bill, this plug-in model is a really good fit. And you know, in this climate zone is just you know, a really good application. Not to say this can't go in other areas, but other considerations have to be considered, you know, like the ambient temperature, just to make sure this is going to be performing at a good level. So as I mentioned, we will have a dedicated circuit model in 40 and 50 gallons. It's going to suit the needs for, you know, 2 to 4 people in the 40 gallon and 3 to 5 for the 50 gallon. Moving to the shared circuit models, we have more size variance there. We're going from 40 to 80 gallons. And again, that 40 gallons is going to suit the needs for your multifamily segments, going all the way up to, you know, larger 5-person families in the 80 gallon unit. We've already completed a third-party NIA testing for the dedicated circuit. We'll have that certification for the shared circuit by the end of the month. And again, we're going to meet both those products will meet NIA Tier 2 testing there. So we're really excited about that. Go ahead and move to the next slide. So for the past year plus, we've actually had these in homes, just to make sure that they work. This is a typical process for manufacturers, just to place these in homes and gather some information and some qualitative research on whether or not this is going to supply enough hot water. Does it meet the expectations of the consumer? As you can see, some of the installations there are prettier than others, but there are lots of different applications, lots of different climate zones, and we've had pretty good results. We're looking to extend that out in June with another half dozen units, just to make sure the right product that we're coming to market with is going to be there. So go ahead and go to the next slide. This is some of the results that we've had. Overall, pretty good. 4.5-star ratings. To pick a new water heating technology. Going from gas to electric. A lot of people don't notice their water heater running. So when you get into some of these trials, people put a little bit more focus on it. And we obviously have the same concerns as everybody else. Does it produce enough hot water, and how loud is it? So as you can see from the results, we get pretty good results on hot water. We don't really have too many hot water or cold water situations from the heaters. And most consumers aren't really bothered by the noise that it puts out. Some of that has to do with the training and making sure the contractor is letting consumers know that this is a new type or a new way to heat water, and there will be some noise associated with it. But again, at a sub 55 dBA level, it's very similar to dishwashers or air registers in your house already. And again, consumers, when they're picking their favorite aspects, obviously being part of a groundbreaking technology is important to them. So more to come on results as some of these field trials continue to flush out. We'd be happy to share that with you. Go ahead and go to the next slide. So really we're expanding our portfolio. Rheem has a pretty strong sustainability campaign or goals going on right now. We want to train 250,000 contractors on efficient products out in the marketplace by 2025. We're also looking to reduce our greenhouse gas emissions and the greenhouse gas emissions in the products that we sell. So heat pump water heaters are a big part of that initiative, as well as having zero landfill impact in production, which we're meeting in a lot of our different facilities across North America. I was in that meeting that Panama mentioned or referred back to in San Francisco, and obviously one of the big questions from the group to manufacturers was, what's it going to take for manufacturers to produce this 120 volt product? That way we can meet the market needs of California. And of course, it's a simple answer. We need help with building the marketplace. So, we continue to ask for help in launching these 120 volt products, supporting them with some incentives. So we've been very encouraged with a lot of the statewide activity that's been proposed, but it is a little concerning that they seem to be a little elusive. They keep moving down the line a little bit. So we just ask for continued support and pressure to get those launched out in the marketplace as we come with innovative products in the market. So with that, I am going to turn it back to Panama.
Panama, we don't have your
Panama, we can't hear you.
There we go. What I was saying was amazing. Great job. You finished on time. Absolutely incredible. This is a 90-minute webinar because we knew that there was a lot to cover and we wanted to have lots of times for questions, which there's just been a ton of in the question box. So thank you to all the presenters for staying on time. So we do have time for questions and answers. And thank you for everyone that's gonna stick around with us for those answers to the questions. So if I could have the 3 OEMs, please come back, and Amruta, please come back on camera. And I'm going to be asking some general questions, and we can have each of the OEMs decide. If you all don't have to answer every question, but feel free to raise your hand or feel free just to come in when you want to answer a question. And same with you, Amruta, as appropriate, please feel free. So first of all, Amruta, the first question's to you. Could you provide some more information about the field testing program? Is that underway right now? What is the schedule, and when do we expect results from that?
Sure. So, the field. So currently we are developing the field study, like the actual site selection characteristics. So yes, it is underway. The development of the field study is underway, and we are also working with utilities on the funding effort. So we are working with, for example, PG&E and Southern California Edison on some of the contractual details, and SMUD is also interested in participating. So the plan is to, like, we are targeting Q3 of this year to actually start with the testings, like with the installations. And again, I would just mention that capturing the winter months is a critical, and that's why we want to like start early so that we are capturing the winter months.
Fantastic. Thank you, Amruta. So and I want to just also reflect on something that Kevin said at the beginning of the presentation, that you know, we are obviously at an exciting stage in deployment of these technologies. Each of the manufacturers are going through their testing, and they're on the verge, on the edge. It depends on how high that edge is based on each different OEM. But and I appreciated that you were so willing to share in front of your competitors. And so thank you all for participating in this and your openness to the conversation. A number of questions about cost and how much these 120 units we can expect them to cost versus a comparable gas unit and a comparable 220 heat pump water heater. Any of you folks able to offer thoughts on cost at this point? Notice I prefaced the awkwardness of being in front of each other right before I asked this question. Kevin, unfortunately, we're not hearing you again. I don't know what's going on. We'll have to keep you off of mute the whole time when you come back in.
Nope.
Nope, still not.
Can't hear you.
Yep. Arthur or Tom, anything you all can say about expectations on cost?
I'd say they should be pretty comparable to a standard 240 volt heat pump. You're talking a whole nother level of technology over, you know, a standard gas water heater that might be the alternative.
Yep. So you're saying it should be comparable to a similar size 220, and with that, therefore, we should see a similar spread between the gas unit costs and the heat pump water heater costs. Okay, great. Tom, see you nodding your head.
I would echo that comment. There's for comparative purposes, for consumer expectations, I think that's a very reasonable perspective to put on it.
Okay, great. Kevin, while you were gone, both of your competitors said they plan on underselling you dramatically. We still don't hear you, Kevin. Not sure what's going on. While we're working on Kevin's audio, a number of questions about first hour heating and delivery, and a number of folks, you know, haven't been exposed to those concepts much based on the questions. So, Tom, could you just go over first hour heating and delivery real quick, the concept, and then could each of the OEMs talk about how they're addressing it in their 120 volts?
Sure, and in its simplest form, it's a standardized test that we as manufacturers have to run to characterize the performance of our unit in delivering water at a set temperature over a prescribed period, doing standardized draws. And that test allows you to operate inside of the test until you can no longer recover to the temperature needed. So it's a very standard way to assess the ability of a product to provide ongoing water supply at temperature through that first hour.
Great. And then number of questions about integrated mixing valves. And there seem to be some differences between the OEMs that were pointed out in the questions. And so could I just have each of the OEMs talk about your planned 120 volt models, whether or not you're including integrated mixing valve in your decision process around that? I noticed that Tom, you said absolutely for GE. Kevin, you said you're going to have a model with and without. Arthur, I wasn't quite sure. So could each of you just talk about your thought process on integrated mixing valves and whether you include them or not and why? Okay, we'll go Tom, Arthur, Kevin.
Yeah, I'll be happy to start. As I mentioned, this is a feature enhancement we have taken to market already in our standard electric heaters. So for us, the capability that provides as a feature that we had already developed was a natural carryover for us to try and bridge some of the concerns that we expect from consumers relative to available hot water.
Arthur?
So I think all three of us basically walked through the same sort of decision or trade-offs. So generally speaking, a gas water heater has a lot faster recovery, as Tom talked about in his presentation. And so to get comparable or similar performance out of an electric, you really only have a couple choices. You can go bigger in capacity, or you can heat the tank up hotter, store more thermal energy there, and then mix back down to whatever the homeowner or the user has requested their outlet water temperature. So I think we followed a similar path in terms of using an integrated smart valve to do more thermal storage within a 120 volt tank, take advantage of a longer heat pump operating time frame, but still meet the hot water needs of a customer.
Great. Kevin, can we hear you at this point?
I don't know.
Yeah, we can.
Yes,
You're back.
we can.
Perfect.
Just in time.
Love to. I think you're just trying to mute me, on the slide. So no, it's it's no different from the others. It's a little bit of a gamemanship between efficiency and hot water delivery for that first hour rating. Anytime that a builder has to meet those goals, we need to make sure that the product is going to deliver a certain first hour rating. So we do have the mixing valve integrated with the lower capacity unit. We don't have it with the dedicated unit, but it could be added on as well after the fact. And the reason why we chose to do that obviously is for cost and for the real need for that. We achieve first hour ratings that are pretty similar to some gas products already out in the field.
Great. Kevin, a couple people noticed a big thing in the middle of your cord. What is that big thing?
I'm sure it's a GFCI. I don't know. I haven't exactly got an explanation yet from product management on that, but I'm sure that's what it is.
Okay, great. Thank you. A couple questions about the different features on this. One about noise. Is there going to be? Are you experiencing any noise differences between your 220s and your 240s and your 120s models? And then will the 120s come with? Will it also come with resistance heating elements inside them as well? And any one of you guys can start.
So I mean, putting a 900 watt element into a 40 or 50 gallon tank is not going to be very effective. So there are no elements in these dedicated heat pump water heaters. So they're no longer hybrid electrics. They are true heat pump water heaters. That's why we removed the element.
So for A.O. Smith, I'll say don't expect any noise differences between 120 and 240 volt products. In terms of elements, so we did choose to include. We recognize there are some times that ambient conditions mean you can't run as a heat pump, or it's rare, but it does occasionally happen. There's some issue with the heat pump that disables it. So we felt it was important to include backup elements just as a secondary heat source to make sure the customer still has hot water. But at the end of the day, we do expect almost all or maybe entirely all of the water heating to be done by the heat pump itself to maximize that efficiency.
Great. Thank you, Tom.
Yeah, our approach is going to be to include that hybrid electric characteristic. We will have those elements in play and utilize them in a similar way to what we've done in the past. The difference, as Kevin mentioned, is the limitations of the wattage for the element you can apply and the level of impact it can have. So expect something similar. And around noise, the industry in total, I think all of the manufacturers have been very sensitive and reacted to noise and developed quieter packages over time. That work continues. I don't see it necessarily differentiated between the 240 and 120 volt as much as just an ongoing focus on that characteristic of the product in general.
Great, thank you. A number of questions in here, just more general to heat pump water heaters than 120, but I think it'd be valuable to hear your guys' perspectives as leaders in this field. So a number of questions about refrigerants. And what refrigerants are you guys planning on using in these models, and does that differ at all from your 240 models? And then just what is the state of play on refrigerants from your opinion in the market right now, and where are we going? And what trade secrets are you willing to let out today on the webinar? It will start. Go ahead, Tom.
I'll start. Be happy to tell you that I won't share any trade secrets. Predetermined path for refrigerant. What I would say is as a company, obviously we play in a number of product categories, and refrigerant generational development is part of what we have to do naturally. We are doing that same thing for heat pump water heating. We are not planning to differentiate refrigerant between the 120 or 240 volt platform, because there is also a characteristic that exhibits in the field when you have to service products, and the more differentiation you put into the field, the more complex that equation is. So.
Yeah, Arthur or Kevin?
Yeah, I'll just say that we are planning on using the same refrigerant as our 240 model, and playing in both the air and the water business. As a manufacturer, we have to not only look nationally but even globally on where refrigerants are going. So we're keeping our eye on future regulations and the desires of the marketplace.
Yeah, it's definitely a period. We're heading into a period of transition, phasing out the high GWP and shifting to low as an industry, or as really beyond just water heaters or heat pumps. So it's something we're keeping a close eye on and evaluating all the options, particularly as new refrigerants get developed and come into commercialization.
I just want to mention that based on the analysis done by NRDC and also internally by NBI, as in we found out that these are all closed loop systems, so there is not much of a, like just transforming the market with the products that are available currently is more critical than waiting for low GWP, like the newer set of products. So as Advanced Water Heating Initiative, currently the plan is to just move ahead with the current heat pump water heaters with the refrigerants they have available.
Yeah, I mean the great news. Go ahead, Amrita.
I will just finish and let CARB or Environmental Protection Agency, let them take the next step and let them show us the direction, but to move on with what we have available.
Yeah, thank you, Amrita. And I think the good news about heat pump water heaters for folks concerned about refrigerants is that there's a very small amount in heat pump water heater units compared to even residential HVAC, or in particular where the real damage is coming from, which is commercial refrigeration. And these are fully contained systems, and really the issue is at end of life and recycling, and making sure that our local areas have good quality refrigerant recycling programs, and that they're disposed of in a proper way. What I will say, I'll just take a moment. There's a number of people asking about recordings of this webinar. Recordings of this webinar are made available to members of the Building Decarbonization Coalition. If you're not a member, just go to buildingdecarb.org/join, and then you're able to get access to this recording. A number of people have also asked for information from the individual manufacturers related to training, related to hooking them up with installers in their area, and wanting more product information. So we will provide the contact information after this webinar to attendees of the webinar, and you can please feel free to contact them at this point. And what I will say is that particularly in California, we're going to see a surge of money becoming available right around Q3 from a piece of legislation that's implementing incentives for water heating and space heating, all electric water heating and space heating. And so keep your eye out for that program. And then a separate program will roll out probably in Q1 or Q2 of next year, focused just on heat pump water heaters. And so combined between these two programs, we think there's going to be a little over $100 million for heat pump programs. But then in totality, we have about $400 million of building decarbonization rebates rolling out across California to help you with heat pump water heater purchases. What that means is that likely heat pump water heaters are going to be incredibly attractively priced for the California market for the next year plus, and hopefully we'll be able to use these pilot programs as models for future programs, so we'll have continued money coming in for this transition over to high efficiency heat pump water heaters. A number of questions about electrical panels and electrical code. I think all of you mentioned shared circuits. And Kevin, you mentioned the difference between your two products of a shared circuit versus its own circuit. Can you talk about the requirements for the shared circuit models and how that works within the electrical code?
Sure. So if you're in a shared circuit or have multiple plugs on the same branch, you need to limit one usage to 50% of that circuit, which is 7.5 amps. Where the dedicated circuit only has the one leg going directly to the water heater space, only one thing will be plugged into that circuit for that 15 amp circuit.
There's a question, does that impinge on, when there is a shared circuit, does it impinge on first hour delivery or energy efficiency assumptions?
Energy efficiency, again, we're doing different control strategies, right, to meet first hour ratings. That's why the mixing valves are in place, and sometimes internal temperatures are driven up a little bit. So, if you were to run it at 120, the efficiencies would stay the same, but then your first hour rating drops. So again, there's a bit of a gamemanship going on, try to meet both requirements, not only for efficiency, but for first hour delivery.
Tom, we got a number of longtime GeoSpring fans in the chat, and they're wondering about GE's role in the heat pump water heater market right now. And could you just give an update about where you are on product offerings more generally, and where you guys are going?
Yeah, and in a general sense, I'm happy to do that. Obviously, if we've got fans of GeoSpring out there, they're probably quite aware of our history in the category in the industry. So as we stand today, GE Appliances is moving forward into the water heating industry broadly. Some of the products that you'll see available today, we are expanding in the category. We've got additional categories we'll be filling out over time, including heat pumps.
Ralph says he has one and it is nearing time for replacement.
Patients will have one.
A question here is that it seemed like, and I think this is coming in particular from Kevin's map, that there's an emphasis on the 120 volt working better in warmer climates, and also indicates the heat pump water heaters, do require a volume of air around them to access air, and it's a medium microclimate. Any issues with installing the units in existing gas water heater closets? Even if it's in perhaps like a warmer macro climate, and any ideas about how to get more air to the unit? This is more of a, I think, general heat pump water heater question than a 120 volt. But any thoughts on that?
Yeah, so I mean, all heat pump water heaters can be installed in a closet. They just need to be able to access air from somewhere else. So that can be accomplished a lot of times with a full louvered door if it's in an internal closet, or you can duct it. You can duct both legs of it, either internally or externally into the house, or you can duct one leg inside the house and leave a 3/4 inch gap on the bottom of the door to provide either intake or outtake. So there's lots of different configurations for installation. All those will be, listed in the use and care manual as well as the spec sheets.
Great. Apparently, I provided an excitement, but not enough information when I mentioned the incentives coming, because a number of questions coming in about that. So there will be incentives rolling. I mean, so first of all, there's already a lot of incentives in a lot of California for heat pump water heaters. And if you go to switcheson.org, there's a searchable database of rebates based on your zip code. And so I'll tell you your utility, your CCA, other programs available to you for that. But there's a program that'll be rolling out called the Tech program that will be having midstream rebates available for heat pumps, for space heating and water heating. And we will, as BDC, definitely be letting you know when that program is up and running. And as I said, we're expecting and hoping that Q3 is when those rebates will roll out. So we will, as some people have asked, we'll definitely be letting our mailing list know about those programs, and they'll definitely be on the switcheson.org website as well. Another question that's probably more generally heat pump water heater than 120 volt is condensate lines. And any best practices or thoughts on condensate lines, particularly for those closet applications? Anyone? The OEMs? Yeah,
Arthur. For California, because there's so many gas water heater installations, is that the condensate produced by a heat pump water heater, it's not acidic, it's not corrosive, it doesn't need to be neutralized or treated in any way before it's disposed. It can go straight into a floor drain, or if there's not a drain, nearby, you can always go into a condensate pump that could, let's say, lift it out of a basement and out of a home, or any other kind of run you needed to make to dispose of the condensate.
Quick question to the manufacturers, Panama, if I may. So, so what do you think about this technology in colder climates if installed like in internal closet or in garages? Like internally and not so much externally. Do you see it being successful there?
Depends. So like each one of the water heaters will have a cutoff at some temperature. So if there's times of the year where it's going to hit that cutoff, it's probably not recommended. And that's why that map shows, for a typical garage installation, it's not going to drop below that cutoff point. Mm-hmm. Not to say that, if you bring it inside the envelope of the house, then obviously that lifts that objection there, or that barrier.
Okay. Yeah, I just wanted to mention to any like other regions, if you're interested in the field study, please engage. Like we have a good, well-developed study, and it will be great to take that to other regions as well if you're interested. So
Yeah, and really, again, this is going from a gas water heater to a heat pump. So the area really needs to be primed for fuel switching. And, a lot of incentives across the country do not allow fuel switching. So that's one of the steps that the area needs to make before, 120 volt product can be successful there.
So, Ralph had like a couple of minutes. He wanted to just address the group Panama if we have a couple of minutes. Ralph,
Sure.
Are you there?
Well, I just wanted Ralph Dinola, CEO of New Buildings Institute. So I just wanted to thank the manufacturers for partnership on this and the Building Decarbonization Coalition. Panama, it was just a little more than 2 years ago that we held that retrofit ready heat pump water heater summit. And to have actual products coming to market in such a short time is real testament to the leadership of these manufacturers and I think excitement about the retrofit ready heat pump water heater. So we're thrilled about that. We're also excited to announce that the Advanced Water Heating Initiative is going to be getting support from the US DOE, Bonneville Power Administration, and Northwest Energy Efficiency Alliance for national expansion. We are already doing some work in the Midwest region and are looking at other regions for expansion. So this West Coast initiative, which really came out of that summit, is really expanding to be a national initiative to really drive market transformation of water heating across the nation. And so we understand there are some limitations of the technology and there's so much advancement happening. But again, I think incredible leadership on the part of the industry and a lot of excitement around the policies and programs that are going to drive this market transformation. So thank you again for all of your leadership and very excited to see this transformation take place. So thanks for the time.
Great, thank you, Ralph. Back to the conditioned space. We have somebody from New York calling in and wanting to know, is the 120 going to have any different impact on the microclimate that it sits in than the 240 version? Like, will it have less of a cooling impact than, say, the 240 models when put into a space?
No, I mean, it's the same heating load. So the same amount of heat is captured from the air and put into the tank. And, a lot of cold climate utilities have studied this, and they found that it doesn't really have a drastic impact on the envelope of the house, as long as it's not placed obviously right next to the thermostat. So, just keep that in mind for installation locations. When you're running hot water in your house, obviously some of that heat escapes into the air as well. So it's more of a, almost like a recycling aspect at that point.
Great. And I think one last question, we're going to give it to our BDC Canadian contingent. We have a number of Canadians on the call, also a number of folks from Oregon and Washington. It's looking like for folks that Great Northwest Installations is very interested in talking to the three of you about product for Oregon and Washington. But for the Canadians, a number of Canadians are saying, when will this be available up in Canada? Will it be on any kind of a different schedule for, say, California, United States, or Canada for your 120 volt models?
So I've been in touch with my counterparts in our Canadian team, and there's definitely interest. I'm not entirely sure what the timing will be, but leveraging the same technology that we'll use for our plug-in in California and the US.
Great. And Tom and Kevin are being coy, so I will. I think the best thing to do is, as I mentioned, we are going to, for members of the coalition, buildingdecarb.org/join. If you're not yet a member, you're able to get access to the PowerPoint and the slides, as well as the contact information for these three gentlemen. And then we'll also send out to all registrants of this webinar the contact information for these three gentlemen and Amruta as well, if you have questions about the field study. So I just want to thank, first of all, the OEMs for your leadership and recognizing this market problem and taking the leap of faith to go out and invest your infrastructure, your engineering infrastructure, and your product infrastructure into trying to address this. We thank you for that, and we stand ready to support you in building the demand for this product. Thank you for participating today. Amruta, thank you for your leadership, and Ralph on AWHI. And thank all of you for your work out there, the attendees in the building decarbonization space. It's all because of your work that we're having the successes that we are, and we look forward to working with you on future BDC Presents and out in the marketplace to really drive building decarbonization. So thanks for joining us all today, everybody, and we'll see you out there in the decarbonization. We're shutting down the webinar.
Thanks, Panama.
Thank you all.
Thank you.
Thank you.